So let's go ahead and look at some of the concepts that underline some of these different topics. Now, there are 29 topics on the SAT. I want to start off with the math section, and I want to jump into some of the topics that occur extremely frequently. So it's going to be algebra, advanced math, and circles. What I like about these different topics is that they actually have the same underlying concepts. Now, these concepts are understanding what a line is with the equation, also understanding what the parts of the equation are, and understanding the graph. So let me rephrase that. I need to know that if I see a line, that it's going to be this equation, but I also need to know what happens to that line when I change that equation. And then the last thing is I need to know what that even looks like, because if I don't know what it looks like, then I won't be able to answer my question often. So today, what we're going to do is we're actually just going to look at the line and the parabola. Why? Because I think that's just the easiest place to start, and it'll make the rest of this all make sense. So we'll have a few different pages of notes, but let's go ahead and dedicate one page just to the line, and then we'll have one page just for the parabola. All right, everyone, so we're going to talk about lines for a bit. Now, lines are the simplest kind of equation you'll see, and for the most part, it's super prominent on the SAT, especially the first math module. So if you can master these, you'll feel very comfortable getting to that second module where, you can get a lot more points, because if you don't get the hard module on the SAT, your max score can only be 600, but if you get the hard module for the math section, your max score could be 800. So one step closer to getting an awesome score. Now, again, let's just start off with, the line. So I'm just going to title in the corner, line. Let's keep our notes nice and organized. So we have line. Now, there's a type of equation that I call, and other people call a parent equation. It'd be y equals mx plus b. It's functionally, think of it like the most basic form of the equation that you'll see. That's also like complete, so it has enough information to really understand what the equation can do. So in this part here, again, we have y equals mx plus b. There's a lot of places to start, but I'm going to start right here. This looks like this. The most simple form just looks like that. Looks like a line. Now, the line has different properties to it. You might notice the m and the b. Now, these are the most important parts of it. If you know the m and the b, then you'll be able to answer most questions fairly easily. Okay? So the m here, this is the slope. Now, there's a lot of ways to think about this, but I'm going to keep it simple because when you learn it very simply, it's just easy to memorize, and you can get more and more technical as you go. So again, m is the slope. This is functionally like the steepness of the slope, or it's also what we call the rate. But in terms of practically for the SAT, I like to think of it as the rate of change. So I'll put a little note. This is the rate of change. Another way that's really useful to think about on the SAT is going to be the change in y for the change in x. And I'll explain what those mean later, but for now, just have to know what that means. Now, our slope is m, but b, this is our y-intercept. Y-intercept. So the y-intercept is functionally where it crosses the y-axis. So when you have your coordinate plane, you might have a line that touches the axis. Well, pretty much you'll always have it touch the axis unless you're working with different kinds of lines. So for example, a parabola might not touch the y-axis, but a line will generally always touch it unless it's totally vertical like this. And there are some cases where you'll get a line like that, but very few. Let's talk about this though. So this point here where the line crosses the y-axis, well, that's going to be our y-intercept. So for example, if I have a line here, and let's just say my line is y equals 3x plus 4, this tells me where it crosses the y-axis. Awesome. So that's our y-intercept. Oftentimes you'll get these sorts of practice problems that have like real life situations, and they'll ask you, what does this thing mean in this real life situation? Usually in real life situations, it's like our starting point. I'll put a little note. It's our starting point in real situations. Why might it be the starting point? Well, that's because the coordinates for this, at least for this one here, is going to be 0, 4. So my x value here is 0, but in real situations that tends to be our time, or maybe you're creating something like you're creating coffee. You're not going to have negative cups of coffee. So we always just start at 0. So it's 0, 4 here. It's often our starting point for real situations. Let's keep moving though. And we'll make more sense of this. Let's bring this, let's just bring this down for a bit to make it make more sense. So here's some quick examples. First, let's just, I'd recommend having one big coordinate plane. Let's say I just have something like, I'll put these in different colors, but let's have y equals x. Well, that would just be a line that goes through the center here. Why does it go through the center? Well, that's because the y-intercept here is just 0. You see how it doesn't have like a plus some number, some constant number? And this is a 4 here, sorry about that. But it doesn't have anything. So it's functioning like it's saying plus 0. And so this one here is also going up 1 and to the right 1. So the slope here is 1 for this. If they don't write the number 1 in front, that just means it's 1. So if there's no, there might be a 3x, 4x, 5x, but if it's just 1x, then they just don't put anything. They keep it blank there. Okay. So again, up 1 to the right 1, up 1 to the right 1, that's the slope. But let's say that the slope was something else. Let's say the slope was, I don't know, let's draw a blue line. And I'm going to put the blue line as y equals 2x. So we'll put y equals 2x. That's what that might look like. It actually just changes the steepness of it. Like that's what it visually does, is it changes the steepness of it. Now, you might have a situation where they do add that y-intercept. So it might be like y equals x plus 2. In that case, it's going to have the same exact slope as y equals x, but it's just going to be moved up 2. So I might move this one up just like this, try to give it the same slope. So that might be y equals x2. So take a look at the difference between these. So far we have y equals x, goes right through the center. Slope is 1. Then we have y equals 2x, slope is 2. Goes through the center also, but now it's steeper. And then we have y equals x plus 2. It's going to be the same as the first one, but it's going to be shifted up 2. So I like to think of this as being almost like the vertical shift. This shifts it up and it shifts it down. So if I wanted it to shift down, well, if I did y equals x minus 2, well, it would go down 2 from the center. This one here, like this blue one, if I wanted to, I don't know, let's say introduce a green one, and this green one was to have something like it's going to have a slope that's less than 1. So it's going to have like 1/2 x. Well, if it's 1/2 x, then it's actually going to become more shallow. So if I compare it to the black one, it's becoming more shallow. So it went from being really steep like this to now being very shallow. Now, you do have other situations as well. I'm going to just free up some space for myself here. Let me add another color. So let me see. I'll say, I don't know why I don't have the color black. Oh, there we go. So I'm going to add another plane. Let's go ahead and add another situation. So now, let's say for whatever reason I had a line that goes y equals negative 3x plus 4. Think for a moment, what might that look like? What might that look like? If you thought it looked like this, so I'd have to go up 4, Then I have a negative slope, so that's actually going downwards, and it's fairly steep. Doesn't look very steep here, but don't worry, it's fairly steep. It's fairly steep. So what this functionally means is that it's going down 3 over 1. Or in other words, we go down this way 3 and we go over this way 1. And it just keeps doing that, down 3 over 1. That's what that slope means. The negative sign means that it goes from this to this. And then, of course, the 4, this tells us the intercept. Now, there are two intercepts that are extremely important to know always. There's the x-intercept and the y-intercept. So you find these the same way in any question at all. You always find them the same way. So we have the x-intercept. That is going to be, to find it, you plug in 0. For x. Or sorry, for y, my bad. And then for the y-intercept, you plug in 0 for x. This is the case for any equation you'll encounter on the SAT. You always find the x-intercept, you always find the y-intercept, just like this. There's no other way to do it. So easy enough. So what does this mean? Well, let me just give you a quick example. So for example, if I had this line here, y equals, I'll say 3x plus 2. I'm just going to draw it really quick. You're going to have up 3 over whatever, and it's going to have a y-intercept of 2. It's going to look something like this. Okay. So if I want to find this value here, fortunately, if you have a line equation like this, you can just look at it and you'll be fine. But if for any reason you couldn't do that, so maybe in a more complicated equation, or let's say they just rearrange this to make it look all crazy, what can you do? Well, you can just plug in 0 for x. So again, if I'm trying to find the y-intercept, I'm going to plug in 0 for x, so I get y equals 3 times 0 plus 2. This cancels out. I just get y equals 2. If I was trying to find the x-intercept, so this one's a little bit harder to see, what would this value be? Well, I just plug in 0 for y. So I go 0 equals 3x plus 2. And then I just rearrange a little bit. I get negative 2 equals 3x. And then I get negative 2 over 3 equals x. Awesome. Isn't that awesome? So that's how I can find that value. That would be my x-intercept. It would be 0, or it'd be, it would be negative 2 over 3 comma 0. There we go. So there's that. And of course, this one would be 0 comma 2. Awesome. Now, what else do you need to know here? Well, there's a few more things you need to know. Now, let's just think about some terms that are going to tell us that we're dealing with a line. The first thing that's going to give it away is very simple. We're just going to get someone telling us that it's a line. So we'll have this line situation, or they'll say linear, or they'll say increasing it or / decreasing at a constant rate. All of those things just mean that it's linear. Nothing crazy here. That's pretty much it. Okay. Now, the last thing I want to talk about lines is when two different lines intersect. So I'm going to call this a linear systems of equation, and the SAT also calls it that. So we functionally have three situations with systems of equations. The first situation, and here's what I would actually recommend doing. I recommend that you break up your paper into just 3 sections. This does not have to be big because it's honestly not that many notes. So we have three different situations that we're always dealing with. The first situation is pretty much when I have two lines that intersect a single time. So these are two lines that intersect. So it might look like that. And you know what? Let me make that a different color just so it's a little bit easier to see. So I might have one line that's going up, one line that's going down. It doesn't really matter too much. Now, this point of intersection, we call that the solution to the systems of equations. So it's the point where they both have the same value. So they both have the same x and y value just at that single point. So in this case, we have one solution. We have another situation we might encounter. And another situation. Maybe make a little guess. How many solutions do you think there are in this situation here? In this situation, there is never an overlap. And then in this situation here, I'm going to say that they overlap infinite times. It's kind of hard to show two lines exactly on top of each other. We have two lines that are completely on top of each other. How many solutions do we have there? Well, if you thought 0 solutions, you are correct. If you thought infinite solutions for this one, you are correct. Now let's talk about each of these. Now, when it has infinite solutions, that's because these equations are functionally the same equation. So I only want to understand these in terms of the y-intercept and in terms of the slope. So they have the same y-intercept and the same slope. Now the SAT will never just write the same equation twice. They'll kind of like do something funny to disguise it. It's very obvious usually though. So for example, you might see something like y equals 3x plus 4, and then you'll see another equation that's like 3y equals 9x plus 12. You can kind of see that they just scaled it up by 3, and the SAT will do that often, as they'll scale things up and down and see if you notice. So kind of keep that in mind. Now, the next thing is we have the situation with 0 solutions. So this 0 solution situation, they have the same, well, maybe you can spot it out. What do you think is the same between these two? Well, if you guessed it, it's the same slope. They have the same slope, but they have a different y-intercept. If you take a look, one of them is up here and one of them is down here. They each cross that y-intercept at a different point, so therefore they have different y-intercepts. However, that slope is exactly the same, and that's why they never touch. If the slope was even just a little bit different, then they would totally touch. Now, the next thing here is, we haven't talked about this one, but it is the first one we drew. What is the same? What is different? Well, it's kind of a little bit of a tricky one. So for the most part, the m is always going to be different. The slope does not have to be like perpendicular. If you're wondering how do you get a perpendicular slope, well, remember that's the opposite reciprocal. So if I had something that was like y equals 3x, the slope here is 3. The opposite reciprocal would be 1 over 3. So this is sort of the perpendicular slope. Okay? So the perpendicular slope would equal negative 1 over 3. Now, we don't need a perpendicular slope for them to intersect. If we did have that, that would be the slope, though, in relation to it. Now, the next part here is the b, though. The b can be the same or different. It's usually going to be different, though, just so you know. So in this case here that I drew, they're different, right? I have one intercept here, one intercept here. Can you think of a situation where it would be the same? Take a moment, think about that. Well, the situation where they would be the same is if they intersected right at the y-axis. So if it was like that. In that case, they have different slopes, but they actually have the same y-intercept. So I actually saw that on a really hard question years ago, and I'm sure they put it every once in a while in the SAT. Okay, so these are the main things that you'll need to tackle for this section. Now, what I would recommend doing now is do some of the questions that are algebra questions, and the systems questions. We'll go over those questions tomorrow, though, okay? Take care.